Last episode 1 promised to show you how your Python code becomes 200 coordinated tasks. So watch this. This line filters 2 terabytes of logs. I run it done. Instantly. 2 terabytes. Filtered in 0 seconds? No. Spark didn't touch a single byte. It did nothing at all, and that nothing is the smartest design decision in Spark. By the end of this video, you'll know exactly what happens between hitting enter and getting your results. First, meet the 3 players. The driver is the brain. It runs your program, holds the Spark session, and plans everything, but processes no data itself. The cluster manager is the staffing agency. The driver asks it for machines, it allocates them. And the executors are the workers, processes spread across the cluster that do the actual computation on their partitions, each on its own CPU, memory, and disk. Remember from last episode, driver plans, executors execute. Today you'll see exactly what the driver plans. Here's the rule that explains the instant filter. Spark operations come in 2 kinds. Transformations, filter, select, group by, with column, describe what you want. They build up a recipe and execute nothing. Actions, show, count, write, collect, say, I need the result now. Think of online shopping. Adding items to your cart moves no merchandise. Only checkout does. Filter is adding to cart. Show is checkout. Until you call an action, Spark just takes notes. That's called lazy evaluation, and it's not laziness. It's patience with a plan. Why is doing nothing smart? Because the moment you call an action, Spark sees your entire recipe at once and rewrites it. Say your last step keeps only 2 columns and 1 month of data. An eager engine would read everything, then throw most of it away. Spark's optimizer pushes that filter all the way down. Read only those columns, skip everything outside March. Same result, a fraction of the work. You couldn't do this if every line executed immediately. You can't optimize a plan you haven't seen. So what do the driver's notes look like? A DAG, a directed acyclic graph. Graph, boxes and arrows, each box an operation. Directed, data flows one way, from files to result. Acyclic, no loops, it never goes backwards. Every Spark program you'll ever write becomes one of these. Read, filter, group, count, sort. 5 boxes for arrows. This graph is the real program. Your Python was just the way you described it. Now the action fires, and the driver turns that graph into work in 3 levels. One action triggers one job. The job gets cut into stages, groups of operations that can run without moving data between machines. And each stage becomes many tasks, 1 task per partition. 8 partitions, 8 tasks, running in parallel on the executors. That's the answer to episode 1's question. Your 1-line count becomes 1 job, a few stages, and hundreds of tasks, and you never had to think about any of them. But why do jobs split into stages at all? One word, shuffle. Take group by endpoint. Rows for /API/login are scattered across every machine in the cluster. To count them, all matching rows must meet on the same machine, so data physically travels over the network. That's the shuffle, and it's the most expensive thing Spark does. Everything before the shuffle is one stage. Everything after is another. Stage boundaries are shuffle boundaries. Remember map reduce from last episode? Map, shuffle, reduce, the shuffle survived. It's still the toll bridge every distributed engine has to cross. Enough theory, let's watch it happen. Same query as last episode. Read the web logs. Keep the errors. Group by endpoint. Count. Sort. Spark ships with a live dashboard. The Spark UI, on port 4040, and here is what it shows. 3 jobs. The first is just Spark peeking at the files to figure out the schema. Then the real one. 1 stage with 4 tasks, 1 per partition, because we read 4 log files. Then a shuffle carrying barely 2 kilobytes. Only the subtotals travel, exactly like the election ballots. And a final stage with a single task to merge them. 9 tasks in total, planned, shipped, and monitored, while you wrote a few lines of Python. This dashboard becomes your best friend later in the course, when we hunt slow queries. Now the trap that catches everyone in week 1. Spark's plan is a recipe, and Spark does not save the dish. Call count, and the whole pipeline runs. Read, filter, group. Then call show on the same data frame, and the whole pipeline runs again. From the file. Twice the reads, twice the compute. Lazy evaluation means Spark remembers the recipe, not the result. One more consequence, since errors are lazy too. A typo in your filter on line 3 won't explode until the action on line 9. The error message points at show, the bug is upstream. Now you know where to look. There is a way to make Spark remember results. It's called caching, and it gets its own episode. Quick recap. Transformations describe, actions execute. That's lazy evaluation. The driver compiles your code into a DAG, an action turns it into a job, shuffles cut the job into stages, and each stage runs as one task per partition. And Spark reruns the plan on every action. Remember that. So far we've treated data as anonymous chunks. But your data has structure, columns, types, names. Next episode, the data frame, the API you'll use every single day as a data engineer. See you there.